In this video, I will teach you how to solve an inhomogeneous equation, differential equation. Yeah. So you identify a inhomogeneous differential equation when it is not equal to 0. But for a homogeneous equation, it is always equal to 0. For this case, it is not equal to 0. So you have to find the particular integral and also the complementary function. So let's dive into it. The first thing to do is to find the value of m, okay, m1 and m2. And to do so, let's change the left hand side into a quadratic equation by writing it as m squared minus 5m plus 6 equal to 0. So this right now we can solve it by factorization. By going ahead, we have the two numbers that multiply themselves to give us 6 and add themselves to give us minus 5. That's minus 2 and minus 6. So we have m squared minus 2m minus 3m plus 6 equal to 0. So these are the two numbers, minus 2 and minus 3. Alright, so now we can factorize out. We have m into m minus 2 minus 3 into m minus 2 equal to 0. Our goal, first of all, is to find the values of m. So now we can imply that m is equal to 3, that's m1, and m2 is equal to 2. So now we have the two values of m. We can now proceed into solving the rest. Now let's assume that y of x is equal to cx squared plus dx plus e. Now if you should look at the right hand side, this is quadratic because it reduces, the power reduces by 1. So that is why we have this. Now we want to differentiate y with respect to x. So we have the y dx, which will give us 2cx plus d. We'll find the second derivative of y, which will give us the square y dx squared. It will give us 2c. Now we have the second derivative, the first derivative, and the original function. So we input all this into this equation. So by doing so, the square y dx squared, we input it into this, is equal to 2c. So we have 2c minus dy dx. Put it into this, we have 5 into 2cx plus d plus 6 into y. Y is cx squared plus dx plus e. So we have cx squared plus dx plus e, all equal to x squared. So now we have this already. The next thing to do is to open the bracket. Now we have 2c minus 10cx plus 5d plus 6cx squared plus 6dx plus 6e, all equal to x squared. Now the next thing to do is to collect like terms. Group the ones that have the same term together. Now let's look at it critically. X squared should stand alone. So we have 6cx squared. The ones that have x, we have minus 10c plus C6D x, and then we have our constant, which is what? Plus 2C plus 5D plus 6E, all equal to x squared. So we have successfully grouped each term together. The next thing to do is to compare coefficients. Now, the coefficient of x squared here is 1. The coefficient of x squared here is 6c. So we can equate the coefficient. It implies that 6c is equal to 1, which is the coefficient of x squared at the right hand side. So by dividing through by 6, you see that c is equal to 1 over 6. Now we have the value of c already. Let's go to the next term, which is the coefficient of x. Now if you should check the right hand side, we don't have any variable x. It implies that the coefficient of x over here is equal to 0. So we have 10c plus 6d equal to 0. But don't forget, we have the value of c already to be 1 over 6. So we are going to impute it here by saying 10 into 1 over 6 plus 6d equal to 0. 2 in 10, we have 5. 2 in 6, we have 3. So we are left with 5 over 3 plus 6d equal to 0. Now when 5 over 3 comes to the other side, we are left with 6d equal to minus 5 over 3. By dividing through by 6, we will have d to be equal to minus 5 over 18. So this is the value of d. Now let's find the value of e. Now let's come to this constant value. You observe that there's no constant value at the right hand side. So we'll do the same thing by equating this to 0. So it becomes 2c plus 5d plus 6e equal to 0. Now we have the value of d and the value of c. We'll just impute it. So it becomes 2 into 1 over 6 plus 5 into minus 5 over 18 plus 6e equal to 0. Now if you should evaluate everything here, you will have e to be equal to 19 over 108. So now we can imply that our particular integral is equal to, we have the value of c, d, and e. So we are going to impute them into this. So we have cx squared. C is what? C is 1 over 6. So we have 1 over 6 x squared. We have d to be minus 5 over 18. We have this dx to be minus 5 over 18x plus we have the value of e to be 19 over 108. So it becomes plus 19 over 108. So this is the particular integral. But for the complementary function, we have our complementary function over here, complementary function to be equal to a exponential, our first m, which is 3x plus b exponential 2x. So this is our complementary function. So what we are looking for really is the addition of the complementary function and the particular integral. So it implies that pi plus cf, which is the complementary function, is equal to pi is this, 1 over 6x squared minus 5 over 18x plus 19 over 108 plus our complementary function, which is this, which is a exponential 3x plus b exponential 2x. Now this is our general solution to this inhomogeneous differential equation. If you have any question, you can do well to drop it in the comment. Like, share, and comment. Thank you so much.